Hello everyone, my name is Yan Wang, and today I'm going to introduce the Lab 2. So the task 1 of Lab 2 is 2-bit mux. So this is the circuit. So this is how it works. If um if A is 1, Y is 1, so just basically pass through. And if B is 1, Y returns 0. And if A and B both is 1, both are 1, Y returns 1. And if A and B is 1, Y returns 1. If A and S is 1, Y returns 0. So basically, this is how it works. And the task 2 is 4-bit mux. 4-bit mux. So this is the circuit. And let me just introduce this one. So in the JDK wave, you can see A is 2, B is 1, plug it in, is 2, B is 1. It returns 2, so Y here returns 2. And if the SEO is 1, this is the next phase here. If SEO is 1, Y returns 1, Y returns 1. Yeah, so this is it. And the third task. This one. So this is same as the last one. Just added the LED light. So if I plug numbers on it, just present it out, and same as here. This one as well. And if I put this one, the B pass through, the SEO is 0, A pass through. Yeah, so this is how it works. And 2.4, 2.4, 2.4, not. Well, to introduce this one, I have to wait. This one. I have to pull out the table. 2.4 is first times. Here. The table here says converge is 0, negative is 0. Both of them is 0. That may be anything, just pass through. If converge is 0, negative is 1. Still pass through. 2, 2. Convert B1, 0. One's complement. You can see 0 is F, so it's one's complement. If both of them are 1, it's 2's complement, because as you can see, if I plug 1 in, the output is F. This is 2's complement. And 2.5 is and add. So this is and add circuit. Same as the last one, I have to utilize the table here. So if it says it passes 0, add this 0, the function is, you have to know the function, so plug it in. And then we plug it in the number. So you can see, right, this is weird. So 3, 3 returns 3. 4, 3 returns 0. 4, 4 returns 4. And passes 0, add this one here. So this is subtraction. 4 plus 4 equals 5. 4 plus 5 equals 9. 5 plus 6 equals 11, which is B. Then are in 1. A pass through. Wait, I just skip one. So it's 1, 0. 1, 0. A pass through. A pass through. Yeah. A pass through and most of them 1. A still pass through the 6, 6. And 2.6, which is the most complicated one. This one. So for this one, I have to pull out JDK wave. So this is how I do it. I first make the circuit, and then we have to modify the V file here. So it's like a lot. So here like ALU add, ALU and ALU and convert, ALU art convert, and ALU logic, stuff like that. So I created 8 file, I guess. 8 file. And then we have to modify it. And then we pull out that one. So here I make like the test balls here, test values, and I change the file name here, and then just pull out this one, the PowerShell, and plug in the Verilog, this program, and change the name here, change the name here. So you got the brand new BCD file here, and then you can plug in GTK wave. This is like a lot of work. Yeah. So this is how it works. First is add, ALU add. So I let A be 1, A is 1, B is 2, and this one. So it turns 3 here. And then it's 4, 4, 4, 4, turns 8, 7, turns 8. So basically this one is just subtraction. So just like to the end of it. Yeah. And the next one is subtraction. Subtraction, I let A be 5. Wait, is it 5? It's too small. It's so small. 5 cube. 4, 2. Wait, it's not 5. Oh, that's right, yeah. 5, 2, invert B1. 1, pass 0, sum 0. 5, 1. So 5, 2 returns D. So 4, 4. 4, 4. 4, 4. Returns 0. 3, 5 returns 2. 3, 5. Returns 2, and so on. It's just the same. And then it's this one. And n function. N function, I like AB3. AB3. It's AB5, AB3. And all of them are 0. And it returns 1. And overflow returns 1. F here. And then 6. Returns 6. Count returns 1. So I can see this one is correct. And so on. Move to the next one. LU and B and invert. So with this function, invert is 1. Yeah, so only invert is 1. 5, 3. Turns 2. Turns 2 here. Then A6. A 6 is 5. Yeah. A5 is 5. And 3, 2 is 0. So 3, 2 is 0. So this function is correct too. And then this one. What's this? One. Then I make A3, B0. Wait. No, it's still this one too. So it returns E. And then A1. 1, B0 returns 0. B0 returns D. Yeah. So this is our invert function. And then this logic invert. Logic invert. And then A3, B0, R is 0. So yeah. So that's it. It returns 0. It's F, still returns 0, no matter what, it returns 0. And then until this phase, it's 8. And it returns 0, but overflow returns 1. Yeah. And the next one, now it passes 7. So it's 2, 7, 2, and same one. Yeah. Passes 0. So returns 0. AF. Returns 5. And 3, 1 returns 3, 1. Returns 0. 9, 4. 4 returns 4. Then overflow returns 1, and so on. And this is the last one. And we pass. So sin is 1. 0 passes 0. Yeah. So 7 2. 7 2 returns 2. Overflow returns 1. Same as this one. Uh, returns A. Count returns 1. Yeah, so basically this is how it works. Just like move it forward. And I guess that's it. Let me see. Is there anything I have to talk it through? Yeah, I guess that's it.